Hello, my name is Tarek, and in today's lecture we will discuss the conversion of infix expression into the postfix expression. In the last lecture we discussed how can infix expression can be simplified, and that simplified form is easy for evaluation, can be evaluated easily by the computers. The arithmetic expressions that we have in the infix form, that is easy for the humans, but in order to evaluate these expressions, if you want to write a program for the evaluation of those expressions, so that's a bit complex process. To make it simple, the computer scientists have came up with the simplified form of the expression, that is the postfix or the prefix one. So today we will see how can we convert them using this stack data structure. So, so the infix notation is common arithmetic and logical formula notation in which operators are written in fixed style between the operands they act on. Like we have a plus b, or we can also have brackets and other operators to specify the expression. So we have postfix notation. In postfix notation, the operators comes after operand, right? Like here we have a plus b. It will be written as a b plus in the postfix notation. And postfix notation is also called reverse Polish notation. Now in prefix, what we have the operator that come before the operands. So like we have a plus b, it can be written as plus ab, right? And this is also called Polish notation. So in this lecture we will focus on the postfix notation. Okay, so conversion from infix to postfix algorithm. There are some number of steps which we need to follow. So first we will discuss these steps, what can be done, and then we will understand with the help of an example how we can convert an infix expression into a postfix one using the stack data structure. So the first step is scan the infix expression from left to right for tokens. Here tokens we mean the operators, the operands and parentheses, right? So scan the infix expression from left to right for tokens and perform the steps 2 to 5 for each token in the expression. Now what are the steps 2 to 5? Now let's discuss those. Okay, the step 2 is, if token is an operand, append it to the postfix expression. If the token is an operand, if we have like any number 2, 3, 4, whatever the operand is, we will append that in the postfix expression. If the token is left parenthesis like this one, then push it into the stack. We will push that into the stack. Okay, so if the token is an operator, here operator we mean a plus sign, a minus sign, a multiply or a divide. So from operator we mean any plus sign, minus, multiply or division. Here, right? So in this case, pop all operators which are of higher or equal precedence than the incoming token and append them in the same order to the output expression. We will pop all the operators of higher or equal precedence and then the incoming token. If we have a token, like we have a multiplication operator, and in the stack we have a minus operator that's there already in the stack, then we won't pop the minus out, because the multiplication has higher precedence um, than negation. After popping out all such operators, push the new tokens into the stack. After popping the previous tokens, we will push the new one. No need to worry about if you are not getting anything right now, because in the example we will discuss all this and you will get the point. So the fifth and the last point is, if right parenthesis is found, right? If right parenthesis is found, pop all the operators from the stack and append them to the output string or to the output expression till you encounter the opening parenthesis. And pop the left parenthesis, but don't append it to the output string. As we know, in the infix form, we do not have any parenthesis in the expression. That is, it means the postfix or the prefix expression is parenthesis free, right? So now let's discuss. Here's the last point, and that is, when all the tokens of the infix expression have been found, pop all the elements from the stack and append to the output string. If all the expressions have been scanned, then pop all the elements from the stack and append that to the string. Now let's discuss this with the help of an example. Here we have an expression, right? A multiplied by then bracket start, b plus c bracket close minus d division divided by e. So this is an expression here. In place of a, b and c, d, e, we can also write any number, and that can be anyone. So, and this is a stack. With the help of this stack, we will convert our infix expression, our infix notation, into the postfix notation. And how can we do that? We will discuss this right now. Okay. So in the first step, what we will do, we will start scanning the infix notation from the left hand side. This is the left hand side, and we will start this from the left hand side, and we will scan to the right hand side, towards the right one. So first token is A. So we will just append, or we will just write this to the postfix notation. Now, as here you can see, we have A here, right? And this is for the first token. Now the second one is an operator. It's a multiplication operator. So we will push this operator into this empty stack, right? And as you see in the second slide, we have pushed this multiplication, which is static, in the stack. Now we have a bracket. We'll push this bracket into this empty stack, right? Because we do not have any bracket in the postfix notation. So we'll push that into the empty stack. And remember, here bracket means first evaluate this bracket expression. Whenever we use bracket, it means the precedence will be given to the brackets. The brackets have the highest precedence. So in the third step, we have pushed the bracket into the stack. Here we have a bracket. Now we have the operand b, or you can say the next token is b. What we will do with this b? We will write this to the postfix notation. Right, here we have b in the postfix notation. The next token is plus operator. We will push this plus operator to the stack, right? And now in the third slide, we have pushed this plus operator into the stack. Now we have we have the next operand, which is the c, and we will append this c into the infix form, into the postfix form, into the postfix notation, and then the postfix notation will be a, b, and c. Right? Now here's the tricky part. It's not a tricky one, but it is something which we should care about. Now we have a postfix expression, and now we have a closing bracket as a next token. So according to the steps we read in just now, and according to that, we will pop all the operands from the stack till we find the opening bracket, right? So how many operands are there? Sorry, how many operators are there? We will pop all the operators till we find the opening bracket. So how many operators are there? There is only one operator between the closing one and the between the opening and the closing bracket. So we will pop this operator and we'll append this to the postfix notation. So now, as you can see, there is no bracket in the stack, and also we have popped out the plus operator, because we do not append brackets into the postfix notation, and we do not use brackets into the postfix notation. Postfix notation are bracket free. So the next element, the next token in the postfix, in the infix notation, is minus. So here we need to see, is this operator has higher precedence, or the operator in the stack has higher precedence. So as we know, multiplication has higher precedence than the negation. So what we will do, we will first pop out this operator, and then we will push the minus sign into the stack, right? As you can see, we have the minus now here, and the negative sign is in the stack. Because why we did this? Because whenever we will push the operator into the stack, we will first check, is this operator having the high precedence or not. If not, then we will if not, then we will push the operator into the stack, and if yes, then we will first pop out the high precedence operator, and then we will push the lower precedence operator into the stack. Okay, now we have D. We will simply push the D into the stack. Sorry, we won't push D because D is an operand. Sorry, so we will not push the D. We will append the D into the postfix notation, and here we have D. Now we have division operator. So is division operator has higher precedence than the negative one? Yes, division operator has higher precedence. Then we will push this division sign into the stack, right? And now we have E. We will append this E to the postfix notation, and then we will simply just we do not have any postfix notation, infix notation. We have scanned all the expression, and we are done now. So we will simply pop out all the operators from the stack, and here we have successfully converted the infix notation into the postfix notation. So as you can see, with the help of stack, how we can convert our expressions from infix to postfix or prefix. We can also convert this into the prefix, but in this lecture my focus was on the conversion of the infix to the postfix. So this is how we can convert the notation from one form to the another with the help of stack. I hope you got you've understood the process, and in the next video we will implement the evaluation. First we will study how we can evaluate this expression, and then we will also try to implement we will write the code for evaluation of this postfix expression. Thank you for watching.